Hi, everybody. Thanks for joining us. I'm Scott LaPrade, Technical Supervisor here at GenSwiss.
And I'm Bill Fletcher, the Northeast Regional Sales Manager here at GenSwiss.
Today we're going to have a little chat. We're going to talk about our micro bore products from UTILIS of Switzerland. Bill, this is one of my favorite products to show to customers.
Why is that?
Well, the holder and the insert system, the way they work together to orient and self-orient and be effectively quick change, is a phenomenal mating fit with each other. We'll demonstrate one real quickly here. It's as simple as removing the boring bar.
No wrench involved in that?
No wrench involved with it, so finger tight
Cool.
while you're working in the machine. No vice grips or anything. Keep all your tools away from it.
Nice.
The benefit there is you can't distort the holder by over tightening it. And the boring bars actually work in conjunction with the holder in such a way that there's a carbide pin internally in the holder bore, which goes up against the back.
Is that a straight 45 degree?
45 degree on the back
okay.
of the back of the tools.
Okay.
And as it goes back into the bore, it'll orient itself.
It can only go in one of two ways.
You can go in one of two ways. You have to teach your people to not put a boring bar in upside down. But beyond that,
And it's hand tightened once again.
hand tightened.
No tool whatsoever. What is actually holding that bar in there? Is there something going on with that cap as it screws down?
yeah, so internally inside the nut, there's a groove where
Okay.
a snap ring that's on every single one of the tools drops into.
So
The nut presses against that, pushes it back into the bore, and
Yep.
because it's inside of a round bore, it's not keyed in any way other than the angle on the back here. It'll orient itself radially and axially every single time.
So that holder is going down on top of that snap ring, and it's actually grabbing it, and there's a land on that boring bar, and now it's being driven back against that
Carbide
pin.
internal. You can see it kind of goes across perpendicular through the bore that it's
So
resting
the bore
in.
bar is always going back to the exact same location.
Yep. They repeat within about 4/10.
That's
So it's a very effective quick change product, but at the same time very high performance. It is a complete ID working system. So there's geometries for just traditional straight boring. You can do internal threading. You can do internal grooving. We've got full radius grooves right off the shelf out of the catalog, standardized stuff like that. Internal threading, both partial forms and full profile, down to, what do we go down to? About a millimeter? I think an M1.
Smallest opening is 0.017 inch.
Yeah, for some of the boring stuff. But
Yeah.
I think the threading, I think we go down to an M1.
Okay.
So very, very fine internal threads you can generate with these. Maybe in a situation where a thread mill isn't usable, you've got a good option here for internal threading. The entirety of the system is coolant-thru. Let's see if we can show it to the audience here. There's coolant jets on every single boring bar, whether it's a tiny 16 thou min bore size or up to one of the bigger ones like this guy right here is like an 8 millimeter.
So there's the actual borehole that's right in the middle of that 45 degree angle, which is up against that carbide bar in the back. So the coolant will come in from the rear, flow through that hole, and then come out during the ports or the holes that are in the front.
Mm-hmm.
Okay.
Yep. And there's also two variants of every geometry. So there's some where you've actually got for a blind hole situation where the jet comes out the back, where it'll flow around the cutting edge, go through the helical relief or the helical geometry that the bar has, and flush that chip out.
Okay.
So that way the chip is not fighting the high pressure coolant that's coming through the bore. So there's two options for every single geometry that you could utilize in that manner.
All right. I also noticed there's some really unusual on the end of the bore bars here. Some interesting facets or round flats.
I almost forgot about that. I'm really glad you pointed it out. So one of the real nice benefits of the microbore system is every single one of the bars, and I'll rotate it in the light so hopefully you can see it. There's facets around the extension of the neck here, and every single one of them is a slightly different width. None of them are regular. And what that does is it breaks up any chance for harmonics to develop. So you think about it, what's the biggest enemy of a boring bar?
Movement, vibration.
Vibrations. So how do you break?
Harmonics.
You don't want to have harmonics. You don't want to have vibration. Why do they make a bell round? They make a bell round because a bell is conducive to developing a sine wave and a harmonic at a very fixed note.
Okay.
You don't want that with a boring bar.
So that's why they don't leave it cylindrical.
That's why they don't leave it cylindrical with a regular form around it. So having these facets around it really give us the benefit of being able to have a very small diameter at an extended reach over a lot of our competition.
So if you have a boring bar that's rather substantial, such as that, okay, that's one thing. But if you're starting to go into a boring bar that is extremely small, which would really kind of lend itself to vibration, that'd be a very important factor.
Yeah, well, the other thing you got to remember is a lot of our users that are running these already are using it in tougher materials. It's a lot of medical alloys. And
titaniums,
cobalt chromes.
Yeah, okay.
And then a lot of the aerospace users are getting into the things like A286, and then the Hastelloy and that kind of stuff.
High
nickel, high heat. So same thing. You need all as much strength as you can possibly get in the geometry that you're going to be working with.
Oh, that's outstanding.
So one question that I get from a lot of our users on these, when they start working with something down in a range that's small like this is probably, I'd estimate, maybe around 1 millimeter min bore, maybe 1.2, somewhere around there. How do you set that up so to make sure that you're on center perfectly in this direction, in the radial direction, relative to the bore that you're going to be going into?
Yeah, it's very small because very difficult because of the front end being so small. You do have that 45 degree in the back, but how do you know?
How do you know where it is?
Exactly.
So you're putting this into a round bore in your tool position on maybe a drop down on the dog leg in the machine, or maybe into one of your gang slide ID positions or something like that.
How do you figure out everything square?
How do you figure out everything square? You're locking in on just a regular tool flat on the shank here, and as everybody knows, the end of a set screw can come down onto this and actually kind of behaves like a fulcrum.
Yep.
And could cause this to twist in the bore a little bit. So if you're working with something like that's as big as this, it might not be that much of a concern if you're a couple of degrees out of rotation. It'll probably work just fine, though the closer you are to center, obviously the better you're going to be, but this will be a little bit more forgiving.
Okay.
But when you work with something down in this range, you got to be perfect, and you can't see it. And there's not really anywhere to put any kind of metrology equipment on it. So we've kind of come up with a solution for that.
There's no place to measure anything.
There's nothing. Yeah, there's nothing. So to make sure, once you get the holder dead nuts, then all the bars are going to swap in a nice quick change manner, in very very repeatable. But so how do we get there? That's where this guy comes in. So now we've got a gauging plug that can be installed into the holder while the holder's in your tool position, and it gives you a 25 millimeter wide qualified surface that is aligned to the pin inside of the holder. So this gives you a spot where you can put an indicator on and kind of tram across and just see if you get any rise or fall to determine where your holder is. Once you get it so that when you run across this, if it's zeroed on your indicator, you're in great shape and you're ready to take this guy out and install your boring bar and be ready to run.
So is that built exactly the same way as the boring bar tools themselves, going in with the same 45 degree angle on the rear?
Yeah. So the back of the shank is at an angle, which works exactly the same way as the boring tool itself does, but it gives you a position now, and I'll see if I can catch that in a way that the light reflects it. But this is a flawless surface. You're not going to get any interference on that.
I was going to say, that's a high polished, almost like a 4 or 2
It's got to be somewhere around there.
Yeah, it's almost like a mirror.
It's almost like a mirror. So when you're running the tip of your last word across it, or your Minotoyo or whatever, you're not going to get any interference from...
The dial indicator probe is just going to slide across that like glass. Like a skate rink. Yeah.
Just like glass.
Okay.
So that works great on situations where your centering is going to be super crucial on some of the smaller diameter stuff. That gives you a way to actually set the holder up. So now when you're running your job, if that tiny boring bar was to let go, you just grab another one out of the tool crib and put it in, and it's going to be in the same spot that the previous one was. And you're only hand tightening it. So again, you're not going to be over torquing and causing distortion. There's no collets to over torque, and if you over torque a collet, a lot of times you're going to get something skewing a little bit. So there's none of that to interfere with the setup.
So this would be like a huge advantage for, let's say, an inexperienced operator who now has to change out a tool and he's got to make it very quickly. He doesn't have to go for any tools at all to remove the UD cap, to remove the worn bar.
No Allen keys, no accidental use of breaker bars.
And then he can put the tool right back into the exact location where the previous tool was, hand tighten the nut on the top, and you're good to go.
You're good to go.
Wow. No resetups or anything?
Nope.
That's neat.
Nope. So it's a lot of those reasons all kind of really add up to why this is one of my favorite products that we carry.
A lot of really nice features.
There's a lot of really nice features, and it's really easy to work with, and the results that you get are just phenomenal. On that note, saying that we were talking everything is coolant-thru.
Yes.
Another thing that we've been really talking about a lot lately is how to effectively plumb all these great tools into your machine. We do have these kits. And I don't know if you want to talk about that one a little bit there, Bill.
That's what they call the new Nano kits. This is actually available with 3 different sets of lengths. It's a steel braided hose that's good for up to, I believe, up to 3,000 pounds of pressure.
It'll pretty much take whatever your high pressure pump can throw at it.
Oh. And what's really nice about this is the front sections of this are interchangeable. This spins off and can be changed. This spins off and can be changed. There is a quick disconnect feature here as well. So you can either position that near your coolant-thru holder, or you can actually have this at the end where your source of your coolant comes in. The problem with most of these is, oh my God, I don't have the right hardware to hook into my system. Now do I have to go chasing around looking for the right hardware, going on the internet, things like that? Well, what's nice about this kit is it comes complete with all of the various fittings that you might need.
Yeah, starting at M5 up to an NPT.
Yep, comes complete with the precision. As you can see here, there's some very critical joints in here with precision crushable spacers that are provided with the kit. All the tools, so you don't have to go finding wrenches, which is also great. Also, for those unique situations, we've got a couple of great additions. There are JICs on the front, but what's interesting here is that we have one with an M5 and one with an M6, which allows you to put these on either end and allow you to hook into your main coolant line. Again, you have the ability to get this in the Nano, which is 102 millimeters. It is also available with 103 and
130.
130.
Yeah.
Yeah, and then even a longer version of that should you require.
Depending on where you are in the machine, you got to get your lines to it. So
and great, it looks stiff, but then when you really need to move this around, it's got tremendous flexibility, give the ability to get to a lot of different places.
And it's compatible with the micro bore system.
Okay.
So we've got the connection that's used by all the micro bore holders. It's included in the kit, ready to go. Nice and easy.
Time saver, tremendous headache saver.
No more hunting for fittings on the web that just don't exist. It's all included right here.
All in one kit. That's a cool setup. Nice.
Excellent. Well, thanks, Bill.
Thanks, Scott. That was cool.
Yeah. If you're interested in seeing more information about the microbore product, or would like to place an order, please visit www.genswiss.com.